All right, AA SL2. We finally made it through our derivatives and integrals, and now we are going to start our 2 probability learning targets. Today we're talking about the basics of probability, so you guys may know some of this already, but we're going to cover it from a fresh perspective as if you've never seen it before. Probability is always a value from 0 to 1. Like, it wouldn't make sense for somebody to say that something has a probability of 5 or a negative probability. That's just not how probability works. So if something has a probability of 0, that means it is impossible. And if it has a probability of 1, that means it's 100% certain. If it's right in the middle, it means there's kind of an even chance. There's a 1 out of 2. Like if you flip a coin, it has a 1 out of 2 chance of being a heads or tails. The closer you get to 0, the more unlikely that event is, and the closer you get to 1, the more likely event that is. So we're going to deal a lot with sample spaces. Sample spaces, the notation for that is a capital U. That's everything that can happen in the problem. The next little piece of notation is this one right here, where if you put a lowercase n in parentheses outside of either u or other things later on, it's just how many elements that has. So like how many different ways that can happen. Little baby example of that, when you roll a normal hexahedron, also known as a 6-sided die, if there's numbers on the side, like 1, 2, 3, 4, 5, 6, here's all the possibilities. You can get 1 through 6. Then the number, that is the sample space. Like this is U. Whoa, oh, things are really off the rails now. Hold on. Okay, so U is equal to this. So the number of elements in U is 6. There's 6 different ways that can play out. Now, that's the entire sample space, but then we'll often ask you about certain subspaces. Like let's say event A is that you roll a 5. There's only one way that can happen, so the number of ways that A can happen is just a 1. The formal definition of probability for any event is that the probability of A is the number of ways that A can happen over the number of ways that anything can happen in the sample space in capital U. So in our little dice rolling example, there's one way to get a 5, and there's 6 total ways that you can roll a dice. Next example, a fair 20-sided die is rolled. Oh yeah, what's the name for this? This is like a fun fact. Hold on, guys, fun fact coming. A 20-sided polyhedron is called an icosahedron. I'm gonna have to drop that on my D&D friends, that this is an icosahedron. We're gonna let event M be that the number is a multiple of 3. So let's actually list, like we don't have to list out the whole sample space every time, but for the purpose of this problem, I'll do it. All right, there's all 20 of them. So the multiples of 3 are going to be 3, 6, 9, 12, 15, 18. So there are 1, 2, 3, 4, 5, 6 of them. So the probability of event M is going to be that there's 6 ways to roll a multiple of 3, and there's 20 total ways you can roll. Now, you guys, anytime you're giving me a probability, you should default kind of to fractions. And when I say fractions, I mean fully reduced fractions. So this one we would say 3 out of 10. Later on, we might revert to decimals in a certain problem, but that's usually like if they give you decimals in the problem, like if they say the probability of A is 0.25 or something like that, then it's okay to report out as decimals. But in general, fractions are preferred. Now, let's say that 20-sided die, that icosahedron, is rolled 100 times. How many times would you expect a multiple of 3? Well, you can just take how many times it's being rolled and then multiply it times the probability of getting a 3. So we do 300 divided by 10, which is 30. So 30 times a multiple of 3 would be rolled. Now, that's not for sure. Like, if you rolled 100 times, like, you probably wouldn't get exactly 30. You'd probably get, like, 28 or 35 or something like that. But that's how probability works. It's really kind of like the expected part of that is, like, if you were to roll the dice 100 times and then do that a billion times, like roll the dice 100 times, like once, twice, 3, 4, 5, and then record all the number of times that you got a multiple of 3, that eventually they would average out to 30. And 30 times. Next example, we got the colors. Notice the British spelling of cars passing the school gate one morning in the table. So we got a whole bunch of different colors and a total of 110 cars that pass the school. Estimate the probability that the next car that passes the school gates will be red. Well, reds, there were 26, so we're going to say the probability of red is going to be 26 out of 110, which is what, 13 out of 55? Then the next part says, if 150 cars pass the next day, estimate the expected number of red cars. Once again, you just take how many things are happening and then multiply by the probability of that event. I should really keep this close. So that is 35.5 cars. I realize you can't have 0.5 of a car, but don't round this. The decimals are still significant. Just like the average number of children in the USA is 2.5 per family. But that doesn't mean that we should round to 3 children, because you can't have half of a child. Now, you guys, the next section of homework is going to cover a lot of Venn diagrams. So there's tons of probability problems that can also be done with Venn diagrams. So let's say that you have a group of 100 students, and of those 100, 40 students study biology, and of those 40, 12 of them study art as well. Then they also say that 36 students study art in general. I'm going to show you guys how to break this down into a Venn diagram. So the classic Venn diagram that everybody thinks of when I say the word Venn diagram is when there's 2 things happening and they overlap. That is the case with this problem, but that's not how they always work. Sometimes the circles are not overlapping. Sometimes a circle lives inside of another circle. There's a lot of different ways to have a Venn diagram. But this turns out to be one of the classic ones where you have 2 overlapping circles. How do I move you? No. Whatever, it's fine. Okay, so this whole sample space is going to be denoted with a U. So whenever you build a Venn diagram, you're going to put a little U on the outside, denoting that the big rectangle is the entire sample space for the problem. Now for this Venn diagram, we're going to say A is equal to art students, and B is equal to biology students. It's nice that they were A and B like that. Weird. So here's our art students, here's our bio students. We know this whole thing has to add up to 100. So we're going to start putting in some numbers that we see. The first thing my brain goes towards is that these 12 kids that are in both classes. So that's a 12 we're going to put right in the middle. Now, the classic mistake I'll see is students will see this. They'll say 40 students study biology, so they'll put a 40 here. But this doesn't make sense because this whole circle needs to add up to 40. And right now it adds up to 52. So we actually have to subtract those 12 kids that are doing both off of the 40 to say there are 38 students that only study, nope, you did math wrong, Jolly, 28. 28 students that only study bio. 12 of them study both art and bio. Now here they say 36 students study art. That means that includes the 12 students that also study bio. So if you take the 12 out of the 36, we're left with 24. Now, you might think that we're done, but 24 plus 12 plus 28 is 64, I believe. But it said that there are 100 students in the problem. So we need to take 64 out of 100, and that means there are 36 students that are not studying biology or art. So it's a lot of like usually kind of finding the center and then subtracting out. It's like, yeah, you start in the middle of the onion and then put the layers back on. This analogy is falling apart. Let's move on. Like an onion falls apart. It's back on track. Some symbols that are going to come up that I think the book assumes that you know, but I'm going to talk about them. This U stands for union. See how the U looks like a union? There you go. That means like putting everything together. I always think of this as the marriage, because if you have like, you know, your wife's stuff or your stuff and then your partner's stuff, when you get married, there's like no more separate stuff. It's just all the same stuff. So all of these things are joined together. It's the union. It's the marriage. Now, intersection looks like an upside down U, but the clever trick I use is that upside down U looks kind of like an N right here. It's pretty weak, but yeah. This means only the shared part. So it's only the overlap that they have. So if you're talking about, you know, I don't have an analogy. I'm sorry. Like, yeah, it's just what they share in the middle. In a group of 50 people, 29 like eating fish, 38 like eating chips. I'm assuming those aren't potato chips. We're talking about fries because this is a British curriculum. And 9 people like neither fish nor chips. How many like both fish and chips? Well, we're going to draw a Venn diagram. Make sure to put my U on the outside. Now, there are people that like both. So this is going to be another classic Venn diagram where there's going to be overlap in the middle. So let's put fish on one side, chips on the other. So in a group of 50 people, 29 like eating fish. So that means that the whole circle of fish needs to add to 29. The whole circle of chips, they said F and C. I guess I could have used F and C. And 9 people like neither fish nor chips. Okay, this is the part where we can start putting like this 9 people not liking either. That's where we can start sneaking some information in here. So we'll put a 9 right here. That means that these 2 circles have to add up to 41 because there's 50 people in the survey. But if you add together 29 and 38, we get 29 plus 38 is what? It's too early. 67. And I said that this space has to add up to 41. So what that means is there's a lot of people that have been double counted because they like both. So what you do is take the 67 and subtract out the 41, which means there are 26 people that like both. They're the people that have been double counted when you count up the 29 and the 38 together. So we can finally put that middle number and then build the rest of the onion around it. 29 people like eating fish. That means this whole circle has to add up to 29. So this has to be 3. And then 38 like eating chips. So that means this whole circle has to add to 38, which I think that's 12. So the question, the first question they asked is how many people like both fish and chips? There's 26 people that like both. Find the probability that a person chosen at random likes chips. Chips, the whole chips, this whole thing is 38. which means the probability of that is 38 out of 50. And then when we turn that into a reduced fraction, it is 19 out of 25. Both fish and chips is going to be those people in the middle. It's going to be the 26 out of 50, which is 13/25. Fish but not chips. So fish but not chips is this sort of like Pac-Man right here on the left, or like a moon, however you want to think of it. So fish but not chips is 3 out of 50. Because everybody loves fries. What are these three maniacs thinking? Maybe they're a tater tot person. Describe in words F prime UC. Oh, you're using prime. The F prime means not F. So these are people that don't like fish and then unionized with people that like chips. So I guess we can say people who don't like fish or people who like chips. I'm using a sneaky trick in here that just because I've been teaching probability for so long, that anytime you have a union symbol, that means in a word problem using the word or. Anytime you have an intersection, this means using the word and. So people who don't like fish or people who like chips. Now we need to find F prime union C. I'm going to show you guys what that would look like in terms of the Venn diagram. So F prime is everything outside of F. It's people that don't like fish. So that's literally everything outside this circle. So fill in everything but the fish circle. Then we're going to have to unionize that with people that like chips. Now, people that like chips is this whole circle here. So we're going to have to unionize, like marry that to the area we've already shaded. So the extra thing we're going to have to add is these 26 people who like fish and chips together. So these three numbers, 26, 12, and 9, is 47. So that means this is, get back to my color, 47 out of 50. It's really just the three people that only like fish out of there. So yeah, that's our answer. Okay, you guys, good luck with your homework. Please ask me questions in class.